In this video, let us look at important diagrams called quadrant diagrams, which are useful in the simplification of expressions T inverse of T. So corresponding to sine inverse of sin x and cosecant inverse of cosecant x. So corresponding to these two expressions, the quadrant diagram looks something like this. Let us draw the quadrant diagram for sine. So sine is positive, positive, negative, negative. And what is the range of sine inverse and cosecant inverse? Minus pi by 2 to pi by 2. So this diagram is called the quadrant diagram, corresponding to these two inverse trigonometric functions. And this diagram will be useful in solving expressions of this form. For example, if you have sine inverse of sine 280 degrees, 280 degrees, for example. So first what you do is, you can very clearly see that 280 degrees is not in the range of sine inverse. So these two will not get cancelled. So in that case, what you do is, you draw the ray corresponding to the angle 280 degrees. So you know how to draw the ray, right? So what I do is, so I'll rotate the ray through an angle of 280 degrees. So 90 degrees, 180, 270, 280 degrees. So the ray stops somewhere here. Now the ray has stopped in the range of sine inverse. So what you do now is, you just need to find the corresponding angle to this ray measured in the standard convention. So now if you take this ray, what is the standard convention angle correspond to this ray? So we know that if you rotate this by 280 degrees, 270 corresponds to this. So you go an extra of 10 degrees, right? Now, what is the standard angle measured correspond to this ray? If this is 10 degrees, this angle is 80 degrees, but this is measured in clockwise direction. So the angle has to be reported as minus 80 degrees. So the answer to this will be just minus 80 degrees. Minus 80 degrees. Next, if you have sine inverse of sine of 240 degrees. So again, 240 degrees also does not lie in the range of sine inverse. So what you first do is, draw the ray corresponding to the angle 240 degrees. So 90, 180. So 240 lies somewhere here. Let this angle be 240 degrees. Now as you can see, the ray lies outside the range of sine inverse. So what you do now is, you bring this ray into this range by appropriate reflection. The positive side has to go to the positive side, the negative side has to go to the negative side. So this ray is in the negative side of sine, so it has to go to the negative side. So just reflect this ray onto the side corresponding to the negative side. So if you reflect this ray, you get a ray like this. So if this is 240, this angle is 60 degrees. So on reflection, this angle numerically is also equal to 60 degrees. Now what is the angle correspond to this ray in the standard convention? Minus 60 degrees. So the value of sine inverse of sine 240 is minus 60 degrees. Minus 60 degrees. So I hope this is clear. So you can solve some of difficult problems using this also. For example, if you are asked sine inverse of sine 3. You are asked to find sine inverse of sine 3. What is the answer? So let us draw the quadrant diagram for this. So here you have to understand, degrees is not given, and this has to be assumed as radians. So what is the quadrant diagram for this? You are dealing with sine inverse of sine. So plus, plus, minus, minus, and the range is minus pi by 2 to pi by 2. So what is 3 radians? We know that pi corresponds to 3.14 radians. So 3 radians is somewhere near this. So the ray is somewhere here. So this angle is 3 radians. Now this ray lies outside the range, so you have to reflect it onto the positive side. So this is the allied angle. So whatever is this angle is the answer. So what is this angle? Can you measure this? So this angle is 3. This total angle is pi. So what is this small angle? Pi minus 3, right? Pi radians minus 3 radians. So the small angle is pi minus 3. So on reflection, if this angle is pi minus 3, this angle is also pi minus 3. This is measured in positive direction. So the answer for this is pi minus 3. Pi minus 3. As simple as that. Now let us go and see the quadrant diagrams for other inverse trigonometric ratios.